There are so many different types of soil, and there are so many different tests you can do. But you really don't need to get all worried about what type of soil you have too much, because we're creating soil as we garden, because we're partnering with natural processes, we're creating soil. If we're sustainable, we're not degrading soil. In fact, we should be creating soil. So what do we look for in a soil? How do we examine one type of soil to another? They're different colors here, but they're definitely different textures. So over here, I have a soil that's really hardly a soil at all. It's really like a clay. It's a sand mixed with a clay, and we can make it into a sausage. It's a very, very clayey soil, and this wouldn't be very well drained. So that's one particular soil. Here we have another clayey mix, but this is a basalt soil. It's a dark chocolate brown. When we squeeze it, it does make a bit of a sausage easily. It would roll out, but when we try and bend it, it cracks. And you can't quite hear any sand in it. There's not a lot of large particles. I can't feel much on my hands. This one looks quite similar, but this is a sandy loam. There's not a lot of clay in this. It's really hard to get this to, it really won't go into a sausage. I'll try. I can squeeze it into a ball, but it just falls apart. It won't go into a sausage. And I can hear the sand. That's a sharp sandy loam. Easy to dig, very well drained. Now over here, we have a red soil. This is a volcanic soil. And it's got a bit of clay in it. It'll squeeze up a bit. It will nearly roll, but it won't really hold together. There, I've just rolled it up into a bit of a sausage. As soon as I try and put any kind of tension on it, it just falls apart. This has some clay and some fine volcanic material. So there's a red volcanic soil, probably quite a lot of minerals in it. But remember, we're not exploiting the soil, we're just working with it. Over here, I have a fine soil. This soil's very fine. There's no large particles in it. It's a lighter brown than the basalt. It's got some clay particles, but this is a river silt. This is a mixture of river flat soil, a little bit of sand, a little bit of silt, a little bit of clay. It's a whole mixture of river flat soil. Probably quite fertile, but again, we don't really want to exploit the soil. We want to work with it. We'll work with the textures. We'll adapt the type of systems we use. It smells good. It smells earthy, as if it has a lot of organic matter. This one, no smell at all. Not a lot of organic matter in there. It's really just red. The basalt smells quite earthy too, but the clay content is probably actually holding that up a bit. Yeah, it smells quite earthy when you finger your way through it. Okay, our sandy soil. It is darker than the grey sand it originates as, and it also has quite a bit of organic matter. And then we have our clay. Can't really smell it in there at all. That's airless, that clay's airless, and I'd gamble that's a little bit acid. This soil, being very sandy, has got a lot of air in it. It's probably nowhere near as acid, and if it was in a desert, it would definitely be alkaline. So what's the difference there? Alkalinity and acidity. They're what we call the pH scale. If it's a low number on the pH scale, it's acid. If it's a high number, it's alkaline. Dry environments, sandy soils, the beach, the desert, they're alkaline. They're more caustic. And the waterlogged soils and the wet, humid environments, they're acid. We could adjust the acidity with lime, and we could adjust the alkalinity with sulfur. But in nature, you don't really need to do that. it's the environment and the organisms and the life that actually adjust the pH closer to being a neutral pH. We can adjust our pH a little bit with lime and sulfur if we like, but if we're doing the right thing, the pH will adjust itself with all the life cycles. If we have a neutral pH or a pH that's close to neutral, more of the elements of the soil are available to the plants. And if it goes a little bit acid, some plants will germinate because they'll prefer that acid condition. Thistles harvest iron and copper when the pH is a little bit away from neutral, and they're a good indicator of pH condition. So you can use your weeds as indicators of pH as well. It's another system of soil analysis, but we prefer a pH just a little bit acid for our gardens. 6, 6.5, they're good pHs, just a slight bit acid, and the full supermarket shop of the soil is open, and the plant roots can go shopping and get everything they want. Increase your organic matter, increase your soil life by adding food to the soil, add organic matter on top of the soil, moderate its temperature, get it to moderate itself, its own pH. Be careful adding lime and sulfur. We can actually garden on anything.